All right, let's dive in. Today we're tackling dark matter.
Ooh, exciting.
You know, it's funny, you sent me this whole stack of research,
Yeah.
and I gotta say, I'm already feeling like we're stepping into some kind of like cosmic detective story.
I love that.
You know, we're dealing with something that makes up, what, 85% of the mass of the universe?
A whopping 85%, yeah.
But it's completely invisible.
It really is a puzzle.
It's like a phantom. It's
Exactly.
like a cosmic phantom. So before we get too deep into the weeds trying to chase down this cosmic ghost, right?
Right.
Maybe we should start with the basics.
Okay.
Like, what is dark matter?
Yeah.
And how do we even know it's out there if we can't see it?
Well, first of all, I think it's important to point out that the term dark matter is actually a bit of a misnomer
Oh, how so?
because it doesn't interact with light the way that regular matter does, meaning it doesn't emit, absorb, or reflect light.
Interesting.
So it's not actually dark in the traditional sense.
Yeah, okay.
It's more like it's just invisible to us.
Oh, I see.
You know, one way to think about it is that
Yeah.
the universe is like a giant cosmic play,
Okay.
and dark matter is like the stagehand.
Oh.
We can't see the stagehand directly,
Mm.
but we see the effects of their work,
Mm.
the sets they move, the lights they control.
I like that analogy.
Yeah.
So we're seeing the influence of dark matter, but not the matter itself.
Precisely.
But how did we even come up with this idea of a cosmic stagehand? Like, how did this whole idea of dark matter even begin?
Well, the story starts back in the 1930s.
Oh, wow, way back.
Yeah, with an astronomer named Fritz Zwicky.
Fritz Zwicky.
He was observing a group of galaxies
Okay.
called the Coma Cluster,
Coma cluster.
and he noticed that the galaxies were moving way too fast, like way faster than they should have been,
Based on
based on the amount of visible matter that was there.
Oh, okay.
The visible matter in the cluster just couldn't account for the gravitational pull.
So it'd be like seeing like a group of dancers just spinning like way faster than their bodies should allow.
Yes.
There's got to be something else giving them that extra momentum.
You got it.
So what did Zwicky think was going on?
Well, Zwicky suggested that there must be some unseen Dunkel Materie, which is German for dark matter,
Dunkel Materie.
adding to the cluster's mass and its gravitational pull.
To make them spin faster.
Right. But back then, his ideas were, pretty out there.
Yeah.
It takes a while sometimes for those big paradigm-shifting ideas to catch on.
Yeah, for sure.
So it wasn't really until, several decades later
Yeah.
that astronomers Vera Rubin and Kent Ford came along
Okay.
and kind of added another piece to this cosmic puzzle.
Okay, so what did they find?
Well, in the 1970s, they were studying how stars move within galaxies,
Okay.
specifically their rotation curves.
Rotation curves.
And what you'd expect is that stars farther from the galactic center, they should be moving slower.
Yeah.
It's just like planets in our solar system.
All right, yeah.
But what Rubin and Ford found
Yeah.
was that stars on the outskirts were whipping around much faster than predicted.
Really?
Yeah.
So it's like finding out those dancers at the edge of the circle?
Yes.
They're moving just as fast as the ones in the middle.
Exactly.
There's no way that works.
Right.
Without some hidden force.
But
right.
It was as if each galaxy had this invisible halo of mass
Uh-huh.
surrounding it,
Interesting.
providing this extra gravity.
Wow. Okay.
And this was really a major turning point
Oh, how so?
because it, brought this idea of dark matter
Yeah.
from kind of this fringe theory to this serious contender in explaining how the universe works.
Wow.
So you have these strange movements in galaxies.
Yeah.
And it was like these pieces of a puzzle that didn't fit, right?
Well, yeah.
And they forced astronomers to consider this radical idea
It is.
that what if there's something invisible out there?
Okay, so we have these galactic discrepancies.
Exactly.
Right, like little hints that something unseen is pulling the strings.
Yes.
But how do we go from like suspicion to solid evidence?
Right.
Like, how do we know that these aren't just, measurement errors or something?
That's where things get really fascinating
Okay.
because we actually have multiple lines of evidence,
Really?
all pointing towards the existence of dark matter.
Interesting. Okay.
One of the most convincing ones being something called gravitational lensing,
Gravitational lensing.
which is a phenomenon that was actually predicted by Einstein's theory of general relativity.
Oh, wow. So
So,
Einstein
yeah.
predicted this.
Yeah, so picture this.
Okay.
You've got light from a distant galaxy
Uh-huh.
traveling billions of years across the universe,
Yeah.
only to be bent
Bent.
and warped by the invisible hand of dark matter.
Okay. I'm already a little lost.
Okay, so it acts like a giant cosmic magnifying glass.
Wait, so we can see the light from these faraway objects being distorted,
Yes,
even though we can't see what's causing the distortion?
exactly.
I don't.
And by measuring the degree of bending, right, how much that light is being bent,
Uh-huh.
we can actually calculate the mass of the object that is doing the lensing,
Interesting.
which is often a galaxy cluster.
Okay.
And what we find is that the mass that we calculate based on this lensing effect
Yeah.
is far greater
In.
than the mass that we can see in the form of stars and gas.
Oh, okay.
So it's like looking at a scale that says there's an elephant on it,
Okay.
but all you see is a feather,
Okay.
you know.
I'm starting to see why this is pretty convincing evidence.
It's pretty wild,
Yeah.
but it gets even more wild
Okay.
because we have even more dramatic examples,
Okay.
like the bullet cluster.
The bullet cluster. Okay.
You've heard of that one?
Have you heard of that one?
Yeah, tell me about it.
So the bullet cluster is the aftermath
Of two galaxy clusters smashing into each other.
Whoa, that's huge.
Yeah. Now, when galaxy clusters collide,
Yeah.
the gas and stars they contain, they interact, they cause friction,
Right.
and they slow down.
Okay, yeah.
So imagine like a cosmic car crash.
Yeah.
A lot of screeching and crunching.
Totally.
So astronomers mapped the mass of the bullet cluster
Uh-huh.
after this collision
Okay.
using, you guessed it, gravitational lensing.
Of course, yeah.
And here's the thing.
Yeah.
They found that the bulk of the mass
Yeah.
had continued moving
What?
right through the wreckage.
Hold on. So the visible stuff slowed down.
Uh-huh. But the source of the gravity just kept going.
Yeah, like it's like two cars smashing head on.
Yes.
The drivers step out unscathed, but the cars themselves just like phased through each other and kept going.
That's exactly what it's like.
Wow.
And so this strongly suggests
Yeah.
that something invisible, dark matter,
Yep.
was responsible for most of the gravity in those clusters.
Yeah.
And it just didn't interact with the normal matter the same way.
Wow. That's incredible.
So the bullet cluster collision really provides some of the most direct evidence that we have that dark matter exists
Okay.
as like a separate entity,
Yeah.
not just like a modification to our understanding of gravity.
So it's not just like some fluke
Right.
of the laws of physics that we already know.
Yeah, it's like the bullet passed right through the target, leaving this gravitational ghost behind.
Okay, you've officially got me hooked.
Right.
Like we've gone from weird galaxy movements to invisible magnifying glasses to cosmic hit and runs.
That's dark matter for you.
It's so clear that dark matter is out there. But
Yeah.
what I want to know is like, what is this stuff?
That's the million-dollar question.
Right.
And it's one that has stumped scientists for decades.
Yeah.
So the hunt for the true nature of dark matter is really where our detective story, I think, takes us next.
Well, then let's get to the bottom of it. We got to find out who or what this cosmic phantom is. Okay, so we've laid out this whole mystery, right? Like dark matter is out there, it's shaping the universe from behind the scenes. But now we got to figure out what it's actually made of.
Right. It's like we have the shadow, but we don't know what's casting it.
Yeah, exactly. So are there any like prime suspects in this cosmic lineup?
Well, physicists have come up with a whole bunch of candidates, potential particles that could make up dark matter.
Okay, so who are like the top contenders on this list?
One of probably the most popular one is something called a WIMP.
WIMP.
Yeah, it stands for weakly interacting massive particle.
Okay.
So these hypothetical particles, they would be heavy, but they would only interact with regular matter very weakly, making them really, really hard to detect.
So they're like cosmic ninjas or something.
That's a great way to put it. They're slipping through the universe unnoticed.
Yeah, so are there any other like suspects on this list?
Oh yeah, there's a whole bunch. We've got axions, which are much lighter hypothetical particles.
Okay.
Then there are sterile neutrinos, gravitinos.
Wow.
The list goes on and on.
So there's a lot of different ideas floating around.
Yeah, and some theories even suggest that dark matter might not even be made up of particles at all.
Really?
Yeah, it could be something totally different, like maybe a modification to our understanding of gravity, or even like a whole dark sector of particles and forces.
A dark sector.
Yeah, like a hidden universe operating alongside our own.
Whoa. Okay, that's a little spooky.
It's pretty mind-blowing.
It is. But okay, so we've got all these theories, but how are scientists actually trying to find this stuff?
Well, that's where things get really ingenious, because scientists are taking two main approaches.
Okay.
Indirect detection and direct detection.
Okay, so what's What's indirect detection?
With indirect detection, they're looking for the byproducts of dark matter interactions.
Byproducts.
Yeah, so for example, if two dark matter particles collide,
Yeah.
they might annihilate each other and produce gamma rays
Right.
or other particles that we can detect.
So it's like trying to find the smoke from a fire,
Exactly. You got it.
even if we can't see the fire itself.
Precisely.
Okay, okay.
And so there are several experiments looking for these telltale signs, both here on Earth and in space.
Okay.
For example, the Fermi Gamma Ray Space Telescope is searching for these excess gamma rays coming from regions where we think dark matter is concentrated, like the centers of galaxies.
Okay, so that's indirect. What about direct detection?
Yeah, so with direct detection, the goal is to actually catch a dark matter particle interacting with regular matter.
Oh, okay.
So think of it like setting a trap, a super sensitive one,
Mm-hmm.
and hoping a dark matter particle stumbles into it.
So we're basically waiting for a cosmic gnat to land on flypaper.
Yeah, pretty much.
Okay, so I imagine these detectors must be incredibly sensitive.
Oh yeah, you're telling me. To shield them from all the background noise like cosmic rays and stuff, they often build them deep underground in abandoned mines or tunnels.
Whoa.
And some experiments use these large tanks of liquid xenon.
Liquid xenon.
It's extremely dense and produces a flash of light when a particle interacts with it.
Okay.
Others use crystals that vibrate ever so slightly when they're struck by a particle.
So have we managed to, snag a dark matter particle yet?
Well, so far, no definitive detection. But the search continues, and the technology is constantly improving,
Right.
With each new generation of detectors, we're pushing the limits of what we can measure, and hopefully increasing our chances of finally catching a glimpse of this elusive substance.
So it's really a waiting game?
It is. And, it took decades to find the Higgs boson.
Oh, right, the God particle.
Exactly.
Oh, wow, yeah.
So the hunt for dark matter, it might require that same level of patience and persistence.
Yeah, that's a good point. Science is often a marathon, not a sprint. Okay, so we've got these epic searches going on, but I also want to know about the bigger picture. What are the implications of dark matter for our understanding of the universe?
Ooh, that's a great question.
How does it affect the way galaxies form and the overall evolution of the cosmos?
Well, remember, dark matter makes up the vast majority of the universe's mass.
Yeah.
So its gravitational influence is absolutely crucial.
Okay.
In the early universe, dark matter acted like a cosmic sculptor.
Mm-hmm.
Its gravity pulling together the clouds of gas and dust that eventually formed stars and galaxies.
So without dark matter,
Yeah.
galaxies wouldn't have even formed.
Galaxies wouldn't have formed in the first place.
Yeah.
And the universe would be a very different and probably much less interesting place.
Wow, so dark matter isn't just some background character.
Right.
It's the star of the show.
It's shaping the entire cosmic stage, and it
Huh.
doesn't stop there. Dark matter's gravitational influence also shapes the large-scale structure of the universe. We see galaxies grouped into clusters, superclusters, filaments, creating this vast cosmic web that stretches across billions of light years.
It's like looking at the brushstrokes of a cosmic artist.
Exactly. It's revealing the hidden scaffolding of the universe.
And speaking of hidden forces, didn't we leave dark energy hanging a bit earlier?
Ah, yes, dark energy.
Yeah, so we were talking about dark matter pulling things together.
Yeah.
But dark energy seems to be doing the opposite,
It does.
pushing the universe apart.
At an accelerating rate.
So it's like a cosmic tug of war
It really is, yeah.
going on between these two forces.
And the outcome of this epic battle, it's going to determine the ultimate fate of the universe.
Bruh.
Will it keep expanding forever?
Yeah.
Growing colder and more diffuse?
Right.
Or will gravity eventually win out, causing the universe to collapse back in on itself, like in a fiery big crunch?
Okay, now those are some high stakes.
They are.
So, do we have any idea which force is going to win this cosmic tug-of-war?
Well, based on current observations, it seems like dark energy is in the lead.
Oh, really?
Yeah, the expansion of the universe is accelerating, which suggests that dark energy's repulsive force is currently dominating.
Okay.
But here's the thing. We still don't fully understand dark energy.
Yeah.
We know it's out there, we see its effects,
Right.
but its true nature remains one of the biggest mysteries in modern cosmology.
So it's kind of like dark matter all over again.
In a way, yeah. We know it's there, but we don't know what it is.
It's amazing to think that these two invisible forces, dark matter and dark
I
energy,
know, right?
are literally shaping the destiny of the entire universe.
Yeah.
It really puts things in perspective.
It certainly does. It reminds us that even though we've made all this progress in understanding the cosmos, we're still just scratching the surface.
That's a good point. There's a whole lot more out there waiting to be discovered. And this quest to unravel the mysteries of dark matter and dark energy,
Yeah.
it's leading us on an incredible journey.
It really is a cosmic exploration.
Well, speaking of exploration, I think we've covered a lot of ground in this deep dive, from the historical hints of dark matter's existence to the cutting-edge experiments searching for its true nature. But I feel like we still have some exciting territory to explore.
Oh, absolutely.
So we've been exploring this shadowy realm of dark matter, right? We've been piecing together the clues,
Yeah.
but it's clear that this cosmic mystery, it's far from solved.
It really is, yeah. It's like we've assembled this giant jigsaw puzzle, but we're still missing a few crucial pieces.
Yeah, exactly. And I have a feeling that those missing pieces could hold like the key to understanding some really fundamental questions about the universe. You know? So as we kind of wrap up this deep dive, I want to leave our listeners with like some of those big unanswered questions, right?
Yeah.
The kind that keep like cosmologists up at night
Well,
staring at the stars.
Let's open up those cosmic questions, see where they lead us.
Okay, so here's one that I find both intriguing and a little bit unsettling.
Okay.
What if we could actually see dark matter?
Oh, wow.
I mean, right now we're only inferring its presence through its gravitational effects, right? But if we could like directly observe it,
Yeah.
how would that change our view of the night sky?
That's such a great question. Imagine looking up at night and seeing not just the familiar points of starlight,
Right.
but also these like intricate sprawling structures of dark matter.
Wow.
It would be like suddenly seeing the scaffolding of the universe.
Yeah.
Right? The invisible framework upon which everything else is built.
It would completely transform our understanding of the cosmos, I think.
It really would.
And that kind of leads me to another question.
Okay.
If we could somehow harness the power of dark matter, what kind of incredible technologies could we create?
Oh, now you're talking. If we could understand and manipulate dark matter, and that's a big if, of course.
Yeah, of course.
It could lead to like technological revolutions that we can barely even imagine.
Like what?
Like, new sources of energy,
Mm-hmm.
revolutionary propulsion systems, maybe even the key to interstellar travel. Who knows?
It's mind-blowing to think about.
It really is.
But for me, like the most profound question is this.
Okay.
What does the existence of dark matter like really tell us about the nature of reality itself? I mean, here's this substance that makes up the vast majority of the universe,
Yeah,
and we still don't know what it is.
it's true.
So, like, does that mean our current understanding of physics is incomplete?
It's possible.
Are there fundamental laws of nature that we haven't even discovered yet?
Those are the questions that really drive scientific exploration. All right?
Yeah.
The existence of dark matter, I think, is a constant reminder that we still have so much to learn about the universe.
It's true.
And it challenges us to push the boundaries of our knowledge, to question our assumptions, to be open to new ideas,
Yeah.
no matter how radical they might seem.
It's humbling, isn't it?
It is.
To realize that we're surrounded by this invisible world, this vast realm of dark matter that we're only just beginning to glimpse.
It's both humbling and exhilarating at the same time.
It is.
It's like standing on the edge of a vast, uncharted territory, knowing that there are incredible discoveries just waiting to be made out there.
Yeah. And the best part is, like, we're not just passive observers.
Right.
We're active participants in this cosmic exploration,
Thought so.
constantly like developing new tools and techniques to probe these mysteries of the universe.
We are.
I think that's a perfect note to end on.
I agree.
This deep dive into dark matter it's been a journey of discovery.
It has.
Like a reminder that the universe is full of wonder and mystery.
And endless possibilities.
And endless possibilities for exploration.
Absolutely.
So thank you for joining us on this deep dive into the shadowy realm of dark matter.
It's been a pleasure.
We hope you've enjoyed exploring its mysteries and pondering its implications as much as we have.
And who knows what the future holds, right?
Yeah.
Perhaps we'll finally detect dark matter particles directly.
Yeah, that'd be amazing.
Or maybe we'll uncover even more profound mysteries that completely reshape our understanding of the cosmos.
It's possible.
Anything's possible.
One thing's for sure, though.
What's that?
The quest to understand dark matter is one of the most, like, exciting and important scientific endeavors of our time.
I completely agree.
It's a journey that's full of challenges, for sure,
Yeah.
but also full of potential for, like, groundbreaking discoveries that could revolutionize our understanding of the universe and our place within it.
Couldn't have said it better myself.
So keep looking up at the stars, keep asking questions, and never stop exploring the wonders of the cosmos.
That's the key.